Hello everyone. So hope all of you are doing well. So in the last session we have seen the theory part of kinematics and we have found these all things which you can see in your screen. So in this session we will be more focusing on the question practice and I have brought you the questions of IIT uh, only advanced and question asked in the JAM exam and some practice question. So here in this session there are few limited question and along with this I'll be giving you more question in the form of DPP which you can find in the description. And in the next session I'll be making the detailed solution. I'll be making the video on detailed solution of those questions which you will have to solve from your side, right? So uh, yeah, as you can see in the last session, we have found the motion of particle in the straight line and motion of particle in the plane. And more importantly, we have found this projectile motion, right? So yeah, now we will be solving some question pertains to these all topics, right? So yeah, this is the first question. You should pause the video and you should try to solve this from your side. So now I'll solve you this for you. So here you can see what the question is asking, that stone is dropped from the balloon which was going up, right? Say this is that balloon which is going up with its velocity has been given, which is 5 meter per second, right? And stone is dropped from here towards downward direction, right? And we need to take the this value of g, right? In the problem solving, what you have to do, firstly you have to write down all those given things that you have been given in that question, right? As here we have been given the initial velocity which is what the 5 meter per second, and we have also been given the height of this uh, like balloon, or we can say the instantaneous height from where the stone was dropped, that was 50 meter, that yeah, that is 50 meter. Secondly, in the last session, I have told you that we need to take the direction of motion as a positive x-axis, right? So here, as balloon is going in this direction, so I'm going to take it as an x-axis, and this would be like negative x-axis, right? Yes. So right after seeing this question, one clear picture should be in your mind that it is the question from motion in a line, straight line, because balloon is going only in one particular direction. So motion is only getting changed only and only in one particular axis, right? So it is the question from where, from the motion in the straight line, right? Secondly, you need to look on those things that you have to find, right? So as here what we have been asked, that we have to find the height uh, of this balloon at particular instant when the stone will hit this ground, right? So that means say we first will find the time interval which this stone will take to reach this ground, right? So how we can find this? By our second equation of motion, which was, right, because acceleration is this, right? Yeah, as I said, direction of motion will be the positive x-axis, and along with this I will have to manage the sign convention, because stone is falling down, so that is why I need to take it as a negative g. So x would be what? X, we have been given the 50 meter, is what the initial velocity, because stone is falling down. So yeah, initial velocity is 5 meter per second, and half t square, right? From here we can find the value of t, as it would become the quadratic equation, and you can solve this like it would be plus or minus, right? From here you need to solve this quadratic equation and you will find the value of time for which at which this stone will hit the ground. And by solving this I will get the time which will be 3.7 second. Yeah, you can try from your side, right? So uh, at this particular time the stone will hit the this ground. Now how much would be the distance that this balloon would have moved uh, in this particular time, uh, and at this particular time that would be what? As we know, velocity is equal to distance upon time. From here you can find the distance which will be velocity into time. So what is the velocity of this particular balloon, which is what we have been given, which is the 5 into, right? So you need to calculate and you need to find this thing. So this will be the velocity of this will be the distance that this particular balloon will move in this particular time. It would be 18.5 meter, right? Now what we have been asked, we have been asked the total distance that this balloon will move uh, when this stone will hit the ground, which would be what? It had already the height of 50 meters, so we only need to add this distance uh, in the given height, which is, so this much would be the distance that this balloon will move when this stone will hit the ground, right? So this is the next question. You should again try this question. So what it is asking that yeah, there is one ball which is kicked with velocity of 20 meter per second at an angle. Yeah, whenever you have been given any particular angle, so you need to immediately get the idea that this is from the motion which is happening in the plane. So that means there will be the two particular axes which would have been undergoing into a change, right? So as there is one particular football and this football is kicked at particular angle which is the 45 degree, and how its path would be, that would be the projectile path like this, and this will be 45 degree. Say this is y axis and this is x axis, right? What we have to find, we have to find the time that it will take to strike the ground. That means it is asking the time of flight, right? So in the last session we have already found that what is the time of flight. Time of flight is this, right? This is the time of flight. You can solve this question directly by applying by putting these values in this formula, or either, or you can go step by step, like at this particular instant what would be there, its y coordinate would be 0. If its y coordinate would be 0, that means total distance that it would have like moved from this point, say this is point A to point B, point A to point B, till here, that would be like what, its range. But see the time that it would take to reach point B uh, would be what, the its time of flight. And how we have found the time of flight, we have found the time of flight from this particular equation. Why? Because acceleration is in the y coordinate, and at this particular instant its y coordinate would be 0, and by just resolving it or simplifying it we will get time which will be, this will be the time of flight that this football will take to reach this point in ground. So we only need to put the values which we have been given. Its initial velocity which is 20, and angle has been given the 45, and sine 45 is 1 upon 100 root 2 upon 10, right? So when we will solve this, uh, we will get what we will get 2 root 2. So this much would be the time that this football will take to reach this point or ground, right? Or we can say time of flight. Second thing, we have been asked that maximum height it would reach. And third thing is how far the kick does hit the ground. So whenever we have been asked the how far, that means we need to find its range, and we know the formula for range. What is the range? Say d is range, which is what, uh, u cos theta time t, right? In the last session we have found the range very in a very thorough detailed manner, so you can watch that session. So here, what is its velocity, which is 20, and cos of uh, 45 is what, again 1 upon root 2 into 2 root 2. From here its range would be what, 40 meter. Yeah, so d is what, 40 meter. So this is the range of this projectile, means its horizontal distance from its initial point to its final point, right? So lastly we need to find the maximum height that this projectile will gain, or like it would be uh, getting that maximum height. So again we can directly put the values on in the formula that we have already found. That was the formula for maximum height, which was what, which was this, right? So just put the values in this formula. So what we will be having, this is the 20 square into sine 45 degree square, means 1 upon 2 into 2 g, which is what, into 10, right? So after solving this we will get the maximum height of 10 meter. The maximum height that this projectile or this football will reach, that will be 10 meter, right? You can check this calculation, right? So let us solve our next question. Yeah, this question is from the vector transformation. In the last session we have read the how one vector transform from one particular frame of reference to another particular frame of reference, right? So in this question we have been asked that one but one man is standing on a road and he is holding umbrella at an angle of 30 degree. Yeah, that means rain is falling on the man at an angle of 30 degree. When he throws the umbrella and start running at 10 kilometer per hour, we need to find what, the speed of this raindrop with respect to road and this man. Okay, say this is ground. Let's say this is the ground. So how rain is falling on ground, like this way, right? So say this is the direction of what, the rain, which is like falling on ground in this direction, and one man is standing here. Okay, one man is standing here, and uh, he, like rain is also falling at an angle of 30 degree on him. What we have been given the angle at which this rain is falling on that man. So that angle is 30 degree. So what is this? This is the velocity of rain with respect to ground, right? And if we resolve this velocity of rain with respect to ground, we will get what, this will be the velocity cos component of this velocity of rain, and this will be sine component. Okay. Secondly, we have been given that uh, man starts running at 10 kilometer per hour. Whenever man is moving, he is moving with respect to ground, right? So this should also be the velocity of man with respect to ground, because man is moving with respect to ground, right? And whenever man is moving with respect to ground at a certain speed, then what happens, this rain falls horizontally, or sorry, vertically, on this particular man. So this should also be what, the velocity of this rain with respect to man, right? Whenever we will resolve, we will be getting this kind of situation. Now we know the velocity transform. What we know the velocity transform, and how we can write the velocity of this rain with respect to ground. That would be this, velocity of rain with respect to ground would be what, velocity of rain with respect to man plus velocity of man with respect to ground, right? We have seen in the last session that how we can transform this vector. So now nothing, we only need to compare its components and we will be getting the solution. What we have been given, we have been given the velocity of man with respect to ground, which is what, 10 meter per second, 10 kilometer per hour, and it should be equal to what, velocity of rain with respect to ground of its sign component. So that means velocity of rain with respect to ground, its sign component is equal to what, velocity of man with respect to ground. And velocity of rain with respect to man in this direction, it has zero, it's zero component, so that means it would be zero. We will have velocity of man with respect to ground, right? So what would be velocity of what is being asked, we need to find the velocity of rain with respect to ground. Velocity of rain with respect to ground would be what, velocity of man with respect to ground divided by this sine component. It would be what, angle has been given the 30 degree, that and this value is 10 kilometer per hour. So sine, that is 1 upon 2, this will be 20, right? Velocity of rain with respect to ground would be 20 what, kilometer per hour, right? Thirdly, we need to find this velocity of this rain with respect to the moving man. Yeah, this thing. Now we need to equate these coordinates, vertical coordinates. So let us equate these coordinates. That means we are only and only putting the values in this equation 1. If we equate these coordinates, obviously, yeah, this thing would be 0. Why? Because man is moving in a horizontal direction, not in vertical direction. That is why the vertical velocity of this man would be 0. So is what, velocity of rain with respect to ground and its cos component should be equal to what, velocity of rain with respect to man plus velocity of man with respect to ground, which is 0, right? Because man is moving like this, not like this. He cannot go under that particular path or that ground, right? So we have already found this is 20, and cos of 30 degree, that would be what, that would be this, and this will be what, velocity of rain with respect to man. So yeah, this will be the velocity of rain with respect to man, and by solving this you can easily find this is 10 root 3. So this is how you need to approach these kind of problem, where the problem is asked from a transformation of vector from one frame of reference to another frame of reference, right? So this is again the question from transformation of vector from one frame of reference to another frame of reference. So I'll giving you this question to you. You should try this question from your side, and uh, I will try to like include this question in my next session. so that you will be understanding that how this question should have to be approached, right? Just because of time constraint, I need to solve you like the question asked in IIT exam. So first we will be solving those questions, and then if time will permit us, we will then coming back to this question, right? Okay, so this is the question which was asked in JEE Advance 2023. It is very recent question. You should first read the question and try to solve this question from your side. Now, what this question is demanding that we need to know the basic trigonometric functions and like how these functions should have to be applied. So this question is only and only about applying the basic things. So how this has to be approached, see here what this is saying, that there is one lamp post and its height is 4 meter, right? And one man is walking before this lamp post, right? And it is uh, it is at a point where this lamp post is very exactly perpendicular to this. So imagine this situation, when this kind of situation would be there, what would be happening? It would be like throwing the light like this, and this man would have its shadow right like this, right? The shadow would be just exactly opposite to this, and this would be what the tip of that particular shadow. And what is the height of man? Height of man has been given, which is 1.6 meter. So what we have to do, we will just join these points and we will get a right angle triangle, right? So let me redraw this. So this kind of situation is there. And this is say that man, and this is the tip of his shadow, right? And this is that lamp post. Say this lamp post is at a distance of y from this the tip of shadow, and let us say man would be at a distance of x. So now what I can do, I can find the ratio of any trigonometric function, but for the slope, as we use the tangent theta, so I will be finding the ratio of tangent theta for uh, this particular right angle triangle and this whole angle triangle, right? So if I will focus only and only at this triangle, so what I will get, its tangent theta, which would be giving me the slope, that would be what, it's perpendicular times the base, right? What is the perpendicular of this, which is 1.6, and what is the base, this distance, what is this distance, this is y minus x, right? This should be equal to what, this tangent theta should be equal to the ratio of this tangent theta for this whole triangle, right? For this whole triangle, what is the tangent theta, that is again this. Now what is perpendicular and what is base, that is y. So this should be like same, this ratio of tangent theta should be same for both of these triangles, because these triangles are identical. I mean, this is just the part of this small triangle is just the part of this bigger one. That is why this ratio should be same. So this should be what, 1.6 meter upon. Now just simplify it. What, right? From here, what you will get, you will get this, which will be equal to what, right? Just let me just make a space. So what we will get, yeah, we will get for x would be equal to what was that, that was uh, this, right? So now let us take its derivative with time, that will be giving us the velocity, right? I'm just taking its derivative with time, or you can see right here, differentiate it with respect to time. Now we know what is dx upon dt, velocity, right? The equation that we have uh, this is the equation, right? We know dx upon dt is the velocity, and dy upon dt is also the velocity, right? See here, velocity is what? Velocity means change in displacement with time. As we have read these all things in very detail in the last session, you can see these all things. So what is y? Y is changing. What is y? I mean, what is the dy upon dt? Dy upon dt is the velocity of this particular tip, and this particular tip is the velocity of that tip of shadow of that of that man. And this is what we have been asked. We need to find the velocity of the tip velocity of the tip of that shadow. So this would be what? Dy upon dt. And we have been given the velocity of man, that is what? This, the change which is uh, occurring in this x variable, right? So that means this is the velocity of man, and this is the velocity of that lamppost, sorry, yeah, that shadow. From here, the velocity of man which we have been given, that is 60 centimeter second inverse, uh, right, by converting it into meter, and you need to also divide from 2.4, that would be dy upon dt. This is what? This is the velocity of that particular shadow, right? So this is what you was asked in this question. Just solve this and find the answer. So now next question is this, and this was asked in JEE Advanced 2022. So what this question is saying, that an projectile is like uh, projectile is thrown in this way, and its angle of projection is theta, and when it reaches its maximum height, it goes into uh, some another zone where effective acceleration due to gravity is g dash, which is given g upon 0.81, right? So how we can approach this problem? What we can do, first we will find the time that it will take to reach the maximum height, and then we will find again the time which it will take to reach its final position, right? And from there we will find the total time that it would take to reach from point A to B, that would be its time of flight, that would be just the sum of its this t1 time and t2 time. And from this its time of flight, we will be able to find its range, right? Remember the thing how we have found the range when we were driving the like this derivation for projectile motion. First we found the time of flight, and then we put that value in the range formula. So here we will find its total time of flight, and then obviously the range, and then we will only need to compare that range with this given range, and we will be able to find the value of n. So yeah, we know from that derivation of a projectile, we know the time that it takes to reach the maximum height is what? Right, this is the time that it will take to reach the h max height. Now because it is undergoing in some another zone, so we need to find the time that it will take to reach from this point to this point. So for this we can use the equation of motion, that was what, uh, half at square. So this equation we will be using, but see here, because at its maximum height it's only would have its horizontal velocity, and it would have its y component which should be maximum, and we know its initial position in the y direction. Why? Because at its maximum point it has its y component which is dominating, right? So that is why we will use this equation. So what is its initial velocity at this particular point along y, that is 0, because sorry, because it only has its horizontal velocity at this particular point, right? So its vertical velocity y, which is 0, and its position, it is at its maximum height, that mean this equation would transform into this, right? So from here t would be what, let's say it is t dash, right? So t dash would be what, that will be h 2h upon g under the root, right? So this is the time that this particular object will take to reach this point from here, right? So we can put the value of this height that it would reach from the value that we have found while we were solving the equations for projectile motion. Right, we know what is the maximum height. This this is the maximum height that the projectile reaches. So put this value in this particular equation. Say this is equation 1, this is equation 2, and this is equation 3. Put the value of this equation 3 in this equation 2. What we will get? 2u square into, this is g dash by the way, yeah, right, sorry, this is g dash and into g dash under the root, right? From here t dash would be equal to what? Yeah, so this would be the value of t dash. From here we can cancel out this 2, and you can see here every terms under the square root has its square, right? So I can very well cancel the square root from the square, and we will finally have u into this root 0.81, and this would have a value of 0.9, right? So the time that it would take from this point to this point is what, is this, that mean that mean this t dash is what, 0.9 times the this. Now see, the total time that it will take to reach from this point to this point will be what, its time of flight, that will be what, that will be the sum of this time and the time that we have driven, right? So that will be what, total time will be what, t plus t dash. Put these values, what we will have, right? So from here or this will be what the total time the total time this body will take to reach from its initial point to final point, that will be this u sine theta, right? This is what, this is its time of flight. And now we can find its range is what, range say d is what, u cos theta time the t is what, the time of flight. So put this value of time of flight in this equation, we will have, right? So from here it will be what, u square, right? So this is what, this is the range or the final range, we could say the final range, that in the question this is given as a d dash. So this final range is d dash, which is equal to this much. Now if you know the basic trigonometric formula, that is sine 2 theta, which is equal to, right, from here if I will divide it by 2, then what I will have, sine uh, right, sine 2 theta upon 2 will be equal to what, sine theta cos theta. So I can put this sine 2 theta by 2 here in this equation, right? So it will be what, u square on 2g times 1.9. Now see, this d dash is equal to what, now we know the formula for range. Let me just clear it. We know what is the range of an projectile. Range of an projectile is what, this is the range of an projectile, and what we are getting this range divided by 2. That means the new range of this projectile is what, its normal range divided by 2 times 1.9, right? This is the new range that we have been getting. And let me just clear it. Okay, so we are getting this thing, right? And we have also been given that this d dash is equal to n times d. Now just compare the things, what would be like n, from here n will be what, 1.9 divided by 2, by comparing this a equation and b equation. So this will be the value of n, that integer which was asked, it would be 1.9, 0.95. This will be the value of this integer which was asked here, right? So this is how you can approach this question. Okay, so next question is again from IIT JEE Advanced. Here in this question, what we have been asked, that there is an projectile which is projected at particular angle which is 45 degree, and when it reaches back oh sorry, there is a an ball, right? When it reaches the ground, it again bounces back, and it its angle of projection is 30 degree. Here it is 45 degree, and we have given its maximum height, which is 120 meter, and we need to find this maximum height, right? So again, we know what is the maximum height, right? Here at this particular instant we have been given this maximum height, so just put the value of this maximum height here, and the angle which is given, angle is theta, which is 45 degree. Here you can see this, right? uh, just take it as a g, right? So from here I can find the value of this velocity, which will be what? uh, upon sin 45 is 1 upon root 2, and its square would be 1 upon 2, and it will be 1 upon 2, it will go here and multiple in its multiplication, and we need to multiply it by 2, so this will be what? 480 g. This is what? This is the its initial velocity, that means velocity at its at that particular instant when it would have its maximum height, which is u square. Next thing is said that when it reaches this particular point, its kinetic energy becomes half of its initial kinetic energy. So yeah, just put this situation. Let's say at this particular instant, this ball would have velocity u dash. So its kinetic energy would be what? Half m time u dash square is equal to what? The kinetic energy that this had at this particular instant, and half of this original kinetic energy, which is what? From here we can find the velocity at this particular instant, right? That will be u dash square, which is equal to what? Upon 2. What was the v dash square? V dash, sorry, what was this u? This is u. Don't get confused in these variables, by the way, right? This is u, the initial velocity that it had, is equal to what? 480 g divided by 2, again 240, right? So from here we got the value, which is u dash square, 240 g. What is u dash? U dash is the velocity at this particular instant. So now we know this velocity, that means the velocity at which this projectile is projected. So we can find its maximum height now, right? Just by putting this velocity in its maximum height formula. So what is maximum height? Again, we have given all these values. This theta for the second projectile is the 30 degree, and 30 degree means 1 upon 2, which should be 1 upon 4, and this u dash square is 240 g into 1 upon 4 divided by 2g. G and g got cancelled out, and from here you can you will find that it will be this, and by solving this you will get 30 meter. So the maximum height that this second projectile would have, which is projected at an angle of 30 degree, that would be 30 meter, right? So yeah, this is how you can solve this question. Yeah, so this question you need to solve from your side. Just because of time constraint, I am giving this question to you, and I'll moving to the IT jams question which was asked in IT jam exam. Okay, so this is very easy question asked in IT jam exam. So you can see here. See, there is one particular block which is kept on its horizontal, which is kept on any horizontal surface, right? And its mass is 2 kg, and the coefficient of friction between this block and this surface, which I could say mu, which is equal to 0.1, and mass has been given 2 kg. And third thing is the force which is applied on this body, that is the force having magnitude of 3 Newton, right? Now when this body would have moved almost 10 meter and it would be here, then we need to find its speed, that how much speed it has moved this much of distance, right? So here what we can do, we can apply the Newton's law, or firstly we need to make its free body diagram, and I'll be making you understand that how you have to make the free body diagram in the next session. So but until that, we will like I'll make that free body diagram and I'll try to like make you understand. So say this is the body of 2 kg mass, and all the forces which are acting on it. One thing is this external force which is acting in this direction, and second thing is the normal force, right, perpendicular to it, and thirdly its weight or mass time acceleration due to gravity, and fourth force would be the frictional force which would be acting against this. Now because motion is happening in the x-axis, so I would be taking x-axis uh, as I would be taking this direction as an x-axis, because like particle is moving in this direction. In any particular direction where this particle object would move, I will take that axis as a positive x-axis. Say particle is moving in this incline in this direction, so I would take this axis as an x-axis, right? And here I need to take this axis as an x-axis. So along with x-axis, because motion is happening, then I need to equate the forces, the forces which are acting on it. First thing is the external force, and second, in the opposite direction, the frictional force is acting, which is equal to its mass time acceleration, right? Because motion is happening in the x plane. Along with y, I have the forces. If it is x, so that this will be positive y, that means normal force minus, because no motion in the y. From here, normal is equal to what? Mg. And we know what is frictional force. Frictional, frictional force is what? Mu times the normal force acting on any particular object. So put this value in this in this equation, equation 1. This, I mean equation 2, put in equation 1. So from here, minus and this, so this is the equation that we will get. Sorry, n time mu, and it will be what? F minus mg time mu is equal to its mass time acceleration. From here, alright, so from here put the values of uh, all those values which we have been given, that uh, 10 Newton of force minus 2 into g, let us take for our simplicity, it's 10, and is equal to what? Is mass time acceleration. Okay, let me just clean it. what we have external force minus mg time its frictional coefficient and is equal to mass time acceleration. From here this is given, and right, so just solve this equation. We would have its mass time acceleration is equal to 8, and that means 8 newton of force is acting on this particular body. From here its acceleration would be what, 8 upon its mass, that would be 4 meter per second square. Now see what we have been asked here, the speed of the block when it has moved a distance of 10 meters. So apply basic equation of motion, which is what, now as we know the acceleration, and its initial velocity was zeros, and we need to find its final velocity or speed, whatever you can say, will be what, 2 times 4, and distance is 10 meter, and it would be what, almost this thing. Yeah. mm, so this should be the velocity of this particular object,